So Laurence, please, would you explain about your technology and your speaking philosophy? Yes?
I'll try, I'll do my best. I'll talk about the technology, but I'll try and keep it reasonably simple, but if you want to talk in detail afterwards, you're more than welcome. When I was first introduced to my business partner Philip Guttentag in South Africa, I came to him from Bowers Wilkins, where I had done the Nautilus loudspeaker, of course, but really what I was wanting to do was to get into professional loudspeakers. So after leaving BMW, I concentrated on making drivers which were more efficient, had a higher power handling, but most importantly, actually performed better. We went into business with our first product, the B1, in 2004, and B1 really encapsulated a number of fundamental technical developments which would follow throughout the history of Vivid and are still with us today. Perhaps the most important thing, as I say, is the diaphragm itself. These dome drivers, these cone drivers, all computer optimized to give us the highest breakup frequency, the largest bandwidth possible. But after the diaphragm itself, the next most important thing is the acoustic environment in which the diaphragm sits. And not only the front acoustic environment, because of course that's the one that we share with the loudspeaker, but the acoustic environment behind the loudspeaker. And then there were a number of other refinements, the shape, of course, the smooth shape without sharp edges, and then things like the reaction cancelling bass drivers. On the original B1 they were front and back, but we've kept with that principle, which still works, and today we have the drivers on the side. The first innovation was the profile of the dome, which we still use in the D50 and D26 mid-range and tweeter diaphragms. The original Nautilus just used a spherical dome, but it already had the inventive step of putting a carbon fibre ring around the edge, which pushed up the first breakup by a useful amount. But it struck me, when I started doing this thing on my own, that perhaps there was a better optimum. And indeed, using computer-aided finite element analysis and optimization, we found that there was a better optimum. This is what we now call a catenary dome. It's the shape that you get if you suspend a chain between 2 points. It's that shape that you get. That catenary dome with the carbon fibre pushed up that first breakup by an octave, nearly an octave. So a really useful margin. The next thing, which again, it followed me from Bowers Wilkins, and I do have the little demonstration for this, was the exponential tube absorber. Now, as I say, the acoustic environment behind the diaphragm is incredibly important, and normally inside most enclosures the sound is allowed to reflect from the walls and bounce around, and certain frequencies will resonate and others will have an anti-resonance. The development of the exponential tube absorber gave us, for the first time, a really properly resonance-free enclosure. And I have this simple demo. If I talk into this tube, you can hear quite clearly that my voice now has resonances. If I just block the end of the tube, you'll hear that the frequency of the resonances changes, but they're still there. And what we need to do is to terminate the end of the tube with an ideal impedance. And that's what this exponential tube does. It terminates the tube, absorbs the sound in a perfect way. So that's what we have at the back of all of the drivers. That collection of novel technology was introduced, as I say, with the B1 back in 2004. And of course, these points are responsible first and foremost for the clarity, the lack of coloration. That's what Vivid Audio has always been about, is a lack of coloration. And Bert is going to play us a track now, a piece of beautiful music which will highlight that clarity, the transparency, the blackness of the blacks, if you wish, that sort of effect.
Omdat je steeds vergat hem bij me op te halen.
At the beginning of the history of vivid audio, it was common to hear at hi-fi shows people saying, oh, it's obviously just a bit of design. There's no serious acoustic engineering going on in here. Of course, that couldn't be further from the truth. I'm an engineer, and I'm proud to say that our products are engineering-led, and the design follows on. One of the striking features of vivid audio design has always been the smooth exterior surface, but it's there for a reason. If the sound coming out of these two drivers, the tweeter or this mid-range, it comes out as a hemispherical wave, and if it hits the hard edge of a rectangular cabinet, it gets re-radiated, and you hear that as a series of peaks and troughs in the frequency response, which change as you move around, I have to say. Whereas if you have a heavily radiused cabinet, and of course we're thinking also of the original B1, which shares this smooth contour, it really does eliminate that sort of a problem. Other aspects of vivid audio design are the decoupling of the reaction forces of the driver from the enclosure. As the cone moves forward, so an equal and opposite force is imparted onto the magnet. Now on its own, the magnet, it's much heavier, it's about 100 times the mass of the cone, so the actual amplitude of the vibration of the magnet is about 100th of that of the cone. So on its own, the actual sound radiation from the magnet is insignificant. But the problem comes when you couple the magnet to the enclosure. I have here a little musical box, which represents the massive magnet with the small vibration, and you can probably just about hear it if I shut up. But if I couple it to a cabinet, then there's no question. A huge increase in radiating area gives you a huge increase in sound level. Now, if the cabinet was a perfect construction, all its resonant modes were thoroughly out of band, I suppose it wouldn't be too much of a problem, but the actual reality is that a cabinet, even ARM cabinets, have structural resonant modes, and these will be excited and various frequencies will be amplified and others compared to others, and you know it's worth eliminating. So what we do is to put silicone rubber O-rings behind all the drivers. So again, hear this, coupled to the cabinet, and then with a silicone O-ring, we're back to negligible sound transmission. So a really simple but incredibly effective little technique there. Of course, when it comes to the bass, it's a slightly different kettle of fish, because the problem there is that the bass, the magnet of the bass driver is so very heavy that to try and decouple the bass driver with just an O-ring at the front would actually be perfectly impossible. To have the softness required to do the decoupling whilst being rigid enough to support the magnet would be impossible. But the solution is a very easy and complete solution, is to just have two bass drivers in opposition, and then the reaction forces cancel completely. As I say, in the first B1, that principle was used with the front and back drivers, but when we moved to the gear, because it's a proper four-way system with separate bass and low mid-range, we were able to put the bass drivers in a much better position, which is on either side of the cabinet. It's true that by removing the reaction forces from the speaker drivers communicating into the cabinet, that's a massive improvement, but it's still well worth making sure that your cabinet is good and stiff, and that all its structural modes are thoroughly out of band, and in our case always higher in frequency than the maximum frequency that will come out of the driver, in this case the bass driver. Gear, in a departure from the original oval, for the gear cabinet, we, for the first time, moved into the use of stressed skin composites, where you have a pair of stiff surfaces separated by a low density core. That the shell is made from such a material is important, but it also requires reinforcement, intermediate reinforcing grids to be placed throughout the structure. And again, harking back to the old BMW days where we had the matrix. The thing about the matrix was that it was in all three directions. The truth is that with a tall, thin structure like a gear, really, it's only the lateral dimensions that need to be stiffened. Now, I've got here a grid from the G1S, which of course is the bigger brother to this loudspeaker. But I encourage you to feel the stiffness and to try and bend this structure. And it really is incredibly light and stiff. This sort of construction is very, very common in the world of aerospace, of Formula One. Wherever a structure has to be light and stiff, people use stressed skin sandwiches like this. A question that people have often asked is, why don't we make, what material do you use? Well, it's glass fibre. And they say, well, why don't you use carbon fibre? Well, the real truth is that we could use carbon fibre, significantly more expensive. But the only real advantage if you use carbon fibre is that the whole thing can be lighter. Whatever resonant structural modes you can achieve with the carbon fibre structure, we can also achieve with glass, but it will be a little bit heavier. If we were sending our speakers into space, then we would make them with carbon fibre. But as long as they are on the ground, possibly with spikes, then glass fibre is all we need. What was the other thing I was going to say about the material? The other thing is that actually the weight of the drivers and the crossover combined, in any case, is greater than the composite shell. So again, if you save 20% of the weight of the shell, it's only 10% of the final product. And if that means paying twice the price for the cabinet, really, it's not worth it. So, I was thinking maybe another basic track to emphasise the structural integrity of our cabinet. How are we doing for time? Yeah, okay. That's fine. Thank you, Bert. See, nice bit of bass articulation there. Now, the last and perhaps the most important feature which really defines the gear which creates this distinctive curly top. The oval series, the original B1 and K1 oval series were acoustically actually just ordinary bass reflex boxes. Yeah, that shape does arguably have offer a slight improvement in terms of internal resonances, but fundamentally you still get a wave bouncing from the top to bottom, side to side, front to back. When we started work on what at the time was our future flagship, we didn't know what it was going to be called, I felt this was the time I had to find a way of combining the exponential horn absorber, which have to work so well, with the bass reflex technique, which does grant you an extra half octave of bottom end for free, in effect, because it's the air in the port that does the moving. But whenever I'd tried it before, basically I got the taper function of the exponential tube wrong, and what would happen was that it would take away the energy of the port. And I must admit, I'd been a little bit half-hearted about it, but this time I meant it. It was for real. And I happened to have a bass reflex box with a top that was that sort of size, and I happened to have a horn with 120 hertz cutoff frequency. So I cut a hole in the top of the bass reflex and stuck the horn out, and lo and behold, it worked. And I have a little demonstration here, which hopefully will demonstrate the effectiveness of this system. So this represents an ordinary bass reflex cabinet, and I'm going to start off with my hand blocking the end. The port equivalent is the hole in the top. And it's just based on an ordinary recorder. And when I blow it gently, that note is the fundamental resonance. It's the air bouncing in and out of the port on the spring of the air in the chamber. And it's the same as the air bouncing in and out of the ports on the side of the loudspeaker. But if you listen carefully, when I first blow, you'll hear a little chuff with some high frequencies. You hear those? And if I blow hard, we can excite those higher frequencies completely. Now, that is waves basically bouncing around inside the chamber. And that's what you get in an ordinary square box. The waves you get, they're called eigentones. The waves are bouncing around between the parallel faces. And you can put wool in them, but then actually what happens is that not only do you damp the eigentones, but you also damp the fundamental bass frequency. The inventive step, if you wish, of finding that if you combine a horn with a cutoff frequency of roughly 4 or 5 times the port frequency, it turns out that you can absorb, you can absorb the overtones without affecting the port. So if I blow gently, you've still got the port, but if I blow hard, you'll just hear the rushing. No single frequencies because they've been completely absorbed. So that was, as soon as we had that basic piece of new technology, that drove the design. As I say, Vivid Audio, the epitome of form following function. So I knew that it was going to be a chamber with an exponential tube. What shape was it going to be? Well, I couldn't forget that the last speaker that I made with an exponential tube had ended up with a spiral. So I, of course, had to do the same thing. And at the time, some people criticised it for being a little bit ostentatious was the word. But actually, do you know what? In the end, I'm very happy we did this because, it really works and it's something to shout about. So that really was the defining technology that created the gear. So the original was the G1, and then 2 years later we produced the G2, and then another couple of years later the G3 and the G4. In 2016, or running up to 2016, we decided that we had to revisit the G1 because, of course, I'd learnt quite a lot of things. Between G1 and G2, there are quite a few differences. So when we released the G1S in 2016, really the G1S is the bigger brother of the G2. The G2 is the first of what I consider to be the good gears. The G1 had a few teething difficulties. The G1S is like a G2 scaled up, and one of the things that we realised was, actually it was for economy, I have to admit, that we decided to use the same motor on the bass driver for both the G1, the G2 and then the G3. And what we found was that actually having what I would call an over-shoved motor in the small box actually did us some favours. I mean, it's well over-shoved. Now, at the time, I was also working for professional sound equipment manufacturer, and they tend to use over-shoved drivers with light cones. And professional speakers, although they can be quite coloured, in the bottom end can be quite fast. And there was a little lesson I thought I had to learn here. So when I came to the G2, I let it be over-shoved. And the cone is also very light. Conventional bass reflex parameters, it flies in the face of conventional bass reflex parameters. It's really much too light and much too over-shoved. But the interesting thing is when you combine it with the passive filter, actually the two marry together in a rather miraculous way. Now, I have to say, there was a certain amount of luck in it at the time, but recently I've revisited this whole field of optimum shove, weight and crossover, and it turns out that by good fortune the G2 parameters are bang in the middle of this sweet spot and really a departure from conventional bass reflex speaker design. Anyway, so there we go. That's my introduction to the gear. Later we'll come back and we'll talk about the Kaya.